Hello, everybody. For our emerging trends topic, we will be talking about augmented reality, where we take a look at ARCore. So, augmented reality, or AR for short, is something that I have been interested in for a while now. I think it would be great to be able to build my own AR app. Over the years, AR has grown so much. From gaming to daily use, there is no denying that augmented reality's influence on the tech industry is slowly changing the web as we know it. It brings the real world and the virtual world together. So in this presentation, we will be discussing what ARCore is all about. The history, some of its fundamental concepts, its advantages, disadvantages, and we're going to be taking a look at the installation. So what exactly is ARCore? Augmented reality, or AR for short, is an enhanced version of the real physical world that is achieved through the use of digital visual elements, sound, or other sensory stimuli and delivered via technology. Now, taking a look at its history. Augmented reality, or AR, has been around for nearly 6 decades. The sketch program, founded by Ivan Sutherland, served as a precursor for modern AR. The Sketchpad program would bridge the gap between user interface and command prompts via intuitive graphical design. So, some of the fundamental concepts of ARCore are motion tracking, environmental understanding, depth understanding, light estimation, user interaction, oriented points, anchors and trackables, augmented images, and sharing. Motion tracking. ARCore uses simultaneous localization and mapping. In other words, SLAM, to understand the phone's relativity to its surroundings. Once feature points are recognized, SLAM utilizes them to compute the change in position in order to calculate the phone's position and orientation with respect to its surroundings over time. The visual information captured by the camera is combined with an IMU, or Inertial Measurement Unit. This is an electronic device that uses a combination of accelerometers, gyroscopes, and sometimes magnetometers to measure and report the specific forces, angular velocity, and sometimes body orientation of an object. The virtual camera used to render 3D objects is now aligned with a device camera provided by ARCore, allowing developers to render virtual objects from the correct perspective. This allows the rendered virtual image to be superimposed on the image obtained from the device's camera, making the virtual object appear to be part of the real-world environment. Environmental understanding. ARCore is always improving its environmental understanding by scanning feature points and planes. It looks for a cluster of feature points that are lying within a common horizontal or vertical surface. Things such as tables, walls, or any surface will be scanned by ARCore, and that info will give ARCore the ability to create a geometric plane with its boundary, and any virtual object will react appropriately to its given geometric plane. Depth understanding. Using the main RGB camera from a support device, ARCore can create depth maps, images containing data with regards to the distance between surfaces from a given point. The information gathered by the depth map can be used to enable immersive and realistic user experiences. Light estimation. ARCore will estimate the current given lighting conditions based on its environment. This will allow ARCore to provide the average intensity and color correction to a given camera image, and therefore lighting a virtual object based on the set lighting conditions, which will increase the realism of the virtual object. User interaction. ARCore utilizes hit testing, taking coordinates that correspond to the phone screen, which projects the camera's view, in which it returns any geometric planes or feature points that the ray intersects. Oriented points. Virtual objects can be placed on angled surfaces with oriented points. ARCore uses nearby feature points to estimate the angle of the surface at the given feature point when performing a hit test that returns a feature point. It returns a pose that takes the angle into account. However, surfaces without texture, for example, such as a white wall, will not be detected properly. The reason for this is that ARCore uses clusters of feature points to detect surface angles. Anchors and trackables. When placing a virtual object, anchors need to be defined to ensure the object's position are tracked over time by the ARCore. Anchors ensure that objects appear to stay in the same position and orientation in space, helping maintain the illusion of virtual objects in the real world. ARCore can update the position of the environmental objects, like geometric planes, and feature points over time. Planes and points are called trackable, which are objects that track over time. Virtual objects can be anchored to a specific trackable to ensure stability between your virtual object and a trackable. A trackable is something that ARCore can track and attach to an anchor. Augmented images. Augmented images lets you create AR apps that respond to specific 2D images by simply pointing the phone's camera at an image. For example, pointing the phone's camera to a poster and a character pops out. Lastly, sharing. ARCore Cloud Anchor API lets its users create a collaborative or multiplayer apps for Android and iOS devices. Now we will be talking about the advantages of ARCore. So first and foremost, ARCore works with Unity 3D and Unreal Engine, as well as native to Android devices, using the Java programming language. Google's ARCore is a steady part of the corresponding operating system Android and is to be used on approximately 100 billion smart devices. Another advantage is Google completes Apple's drive to make AR functions available on all smart devices. Native apps, but also third-party providers' apps, have no access to the native AR functions of the operating system. As a reliable and long-term provider of AR technologies, Google and its ARCore developers offer a steady basis for AR app developments. However, there are also some disadvantages ARCore has. ARCore can only be used in devices with Android operating systems. If an ARCore's application is to be used in a device with an iOS, making it cross-platform, Apple's new AR solution, ARKit, could be used as a counterpart to the ARCore. Even though ARKit and ARCore strive for the same goals, it has to be tested in each case. If every function of a new AR app can be realized on both platforms. We will be talking about the installation. To be able to make your first augmented reality app, here are the following requirements that you need. So for your hardware, it must be an ARCore support device, and you will need a USB cable to connect your device to the development machine. For your softwares, Unity from 27.4.40 to 2020, ARCore SDK for Unity 1.25.0 or later, Android SDK 4.4, which is API level 19 or later, and Android Studio. So first, let's launch our Android Studio. Once it's launched, make sure you select standard, and then feel free to customize your UI the way you want it to. And then it will pop up the screen. And then for SDK, make sure you select API 24, Android 7.0 or over. Once the project is ready, make sure you add the SceneForm plugin. It is very crucial to support AR. On the next video, we will be starting our project with our first augmented reality project.